Hello everyone, welcome to my Mathletes channels. In this video, we will study coordinate geometry and I will also introduce a unique four-step method to solve questions. Now let's start coordinate geometry. Coordinate, there are two words, coordinate and geometry. If we draw a straight line, horizontal line and draw a vertical line, we call these lines coordinate axis. And this line, x-axis, is called coordinate x-axis. And this vertical line is called coordinate y-axis. Where these two lines are made together, we call it origin. And if we take any point in this system, and we can locate the position of this point by drawing the vertical and the horizontal lines. If this distance from here to here is x1, and this distance from here to here is y1, then we can say the point P are x1 and y1. So we can define coordinate is the set of x and y values that show an exact position of a point in two-dimensional xy coordinate system. Coordinates are the x and y values of a point in the xy coordinate system. Now come to the geometry. Take the same figure. If we take any other point over there, and this is called P2, we can also locate the position of this point by drawing vertical and a horizontal line. If this distance from this point to this is x2 and this distance from this point is y2, then we can say the coordinate of P2 is x2 and y2. So if we join these points together, we get a line. So we can define geometry. Geometry means shapes is attained when two points link together. And ultimately, we can define in mathematics, coordinate geometry is the study of geometric shapes using a coordinate systems. Now come to the roadmap of coordinate geometry. There are four topics in this chapter: straight line, types of line, equation of line, and circles. In straight line, we will study midpoint, gradient, and distance between 2 points. In types of line, we will study parallel lines and perpendicular line. In equation of lines, we will study three types of equation. In the first questions, we will study when gradient and y-intercept given. In second, when gradient and 1 point is given. In third, when 2 points are given on a line. In circle, we will study standard and general equations and also see how the line and circle intersect each other and also find the tangent on the circles. Now let's start with straight lines. If we are interested to find out the midpoint between these points, M, the coordinates of this point, we can proceed as follows. X coordinate of M can be obtained by adding x1 and plus x2 of P1 and P2. And similarly, Y coordinate can be obtained by adding y1 and plus y2 over 2. And ultimately, this formula will be obtained, which can be used to find out the midpoint of any 2 points. Now come to the gradient of a line. What is gradient? Gradient is the change in y-axis and change in x-axis. If the change in y-axis is this is up to y2 and up to this is y1. If we subtract y2 minus 1, we will get this distance. So change in y-axis is y2 minus y1. Similarly, in x-axis, this distance is x2 and this is x1. So it becomes x2 minus s1. So we can write change in y-axis and this is change in x-axis. So we can use this formula to find out the slope of any line when 2 points are given. If we draw this line and if this angle is theta, we can also find the slope of a line with this tangent theta, because tangent is the perpendicular over perpendicular over base. This is perpendicular, which is equal to y2 minus y1. This is base, which is equal to x2 minus 1. So we will use this formula when angle is given to find out the slope. If function is given, we can also find the gradient by calculating for its first derivative by this formula. We will study this in detail later on. Now, next is the distance. How we can find the distance between these 2 points? Just draw a lines, and after drawing this line, we get a triangle which is called right angle triangles because this is base, this is vertical hypotenuse. And if this is x2 minus x1 and this is y2 minus y1 and this is d, then we can apply this Pythagoras theorem to find out the distance of from P1 to P2. So we can put the values d P1 to P2 is d, and x P1 and P is x2 minus x1, and P2 P is P2 is y2 minus y1. So take under root both sides, and then ultimately we have this formula to find out the distance between 2 points. Now next is the types of line. There are two types of line, parallel lines and a perpendicular lines. If these lines are given, L1 and L2, first find the slope of this one, then find the slope of this one. If the slope of both lines are equal, then we can say these lines are parallel to each other. If these lines are given, L1 and L2, and we are interested to find whether these lines are perpendicular, first find the slope of this one and this one. If these slope, the product of their slope is -1, then we can say these lines are perpendicular to each other. Now next is the equation of straight lines. First, when gradient and y-intercept is given. Let's see, this is a line L1, and if this distance from this is C, we can define the coordinate of this point because this is on the y-axis, so x coordinate is 0 and y coordinate is C. If we take any other point, general point on this line, then we can find the slope of this line by applying this formula. Put the values of this is y2, this is y1, this is x2, this is x1. So we get this equations, and if we simplify it, we can get this one, and after rearranging, we get final formula to find out the equation of a line when slope and intercept is given. If this type of equation is given, then care should be taken. Here you can see the coefficient of y is 1, so it should be 1. So we divide both sides by 2, we get this equation, and then when we compare this one with this equation, we get slope 2 and y-intercept 4. So next, when gradient and 1 point is given on a line, so this is a line, and 1 point is given over here, and we can take any other point, general point, so we can find the gradient by these two points by this formula. Here we have y2, this is y1, this is x2, this is x1. So ultimately we have slope in this form. If we multiply, move this one over here, we get this one. By rearranging, we get this formula to find out the equation of a line when 1 point and slope is given. Now next is when 2 points on a line is given. Suppose this is a line, point A is given and point B is also given. We can apply a gradient formula. This one, this is y2, this is y1, x2, y1 is the same values. So we get coordinate this one, a gradient of this equation is this line is this one, and if we move, we put the values of this in the previous equations, we get this one. And so after simplifying, this is the final formula to find out the equation of the line when 2 points are given, y1, x1, y1, x2, y2. Now next is the circles. There are two types of equation in the circle, standard equation and general equations. Standard equation is this one. We can also derivate these questions by just draw a circles and take the center point This one, suppose the center points are A, B. Take any other point on a circle. For example, this x1, x, y on a circles. If we draw a vertical line and a horizontal line and make a right angle triangles, so this distance is become x minus a, and this distance will be y minus b. So we can apply Pythagoras theorem to find out the equation, standard equation of the line. Base is this one, and perpendicular is over here. The hypotenuse is r. So put these values over here, we get the standard equation of a circle, where these are the center points and this is the r. The AB are the center point and r is the radius. Now come to the general equations. This is the general equations. We can also find the center points and radius by converting this, by applying the completing square method formula. Just rearrange, move over here, and this with y. And if we add g and also minus g, and I also add f square and also add minus f square, so we can get square of these two, x plus g whole square and y plus y whole square, and move all these to the side. So we can define the, by comparing this equation with the standard, the center point of this equations. Here g is equal to minus a, so we can write minus g minus f. Similarly for f, and radius is equal to this whole terms. Now come to the intersection of a line and circles. The point of intersection between line and circle can be found by solving their equations simultaneously. If line equation and circle equations are given, solve it simultaneously. If the resulting equation is of the quadratic form, then apply this b square minus 4c, which give the following informations. Number one, if b square minus 4ac is greater than 0, we will got real and distinct roots, mean two roots. It means line will touch at the 2 points, here and here. The second condition is if b square minus 4 is 0, real and equal roots, line is tangent to the circle, mean this will be the case. This will be the case, line is touching at 1 point. No, the third condition is if b square minus 4ac is less than 0, no real roots. It means line does not touch to the circles. And this will be the case. This one. Line is not touching. It means there are three possibilities. Line is touching at 2 points, line is touching at 1 point, and line does not touch to the circles. Our next topic is how to find out the equation of a tangent at a specific point on circles. Look at this diagram. We are actually interested to find out the equation of this tangent. In this question, usually center point and point on a circle is given. Let's suppose the center point are A, B, and this point has coordinate x1, y1. And first we need to find out the gradient of this line. We can find this gradient by this formula. Putting these values over here, we get slope of this line is m is 1 is equal to y1 minus b over x1 minus a. And this line is perpendicular to this tangent. So we will apply this formula to find out the slope of this tangent. And ultimately, we apply this formula to find out the equation of this line, because this is passing through this point. And here we have y1, x1, and slope we have already find out from this. Taking these two values, we can find the equation of this tangent. Now, this is the end of the chapter. Now we recap the coordinate geometry formulas. In straight line, we have studied midpoint formula, which is x2, x1 plus x2 over 2 and y1 plus y2 over 2. This can be used to find out the midpoint between 2 points. And we have studied the gradient formula, which is y2 minus y1 over x2 minus x1. And we have already studied the distance formula between 2 points, which is x2 minus x1 whole square plus y2 minus y1 whole square and whole under root. In types of line, if lines are parallel, their slope should be equal. For perpendicular line, the product of slope should be minus 1. In equation of straight line, we have studied three equations of straight line. First one is y is equal to mx plus c when slope and intercept is given. Second, when 1 point and slope is given, we will use this equation to find out the equation of the required line. If line is passing through 2 points, we can apply this formula to find out the equation of the desired line. This is x minus x1 over x2 minus x1. In circle, we have studied two types of equations. One is standard equations, which is x minus a whole square plus y minus b whole square is equal to r square, where a and b are the center point and r is the radius. And we have already studied the general equation, which is x square y square plus 2gx plus 2fy plus c is equal to 0. And in this case, the center point are minus g minus f, and radius is equal to g square plus f square minus c whole under root. Now come to the unique four-step methods to solve questions. This question is given to solve. We will use four-step method to solve this question. These four-step methods are what is given, what is required, what formula we will use to solve this question, and ultimately we solve the questions. So look at these questions. We can predict what is given. A point and B point are given. C is the midpoint is given. Only is telling us about the C is the midpoint. And this equation, which is perpendicular to the required equation, is given. And it is better to sketch a diagram to visualize what is required. Let's see. This line is given. And we are also given the 2 points, A and B. And C is the midpoint between these two, A and B. We have to find out the equation of a line which passing through this point and perpendicular to this line. And in the second part, we have to find out the distance between A and C. On the basis of these informations, given in 1 and 2 steps, we can predict the formulas. And these are the formulas we will use to solve the questions. Let's see how to solve the questions. Part 1. This equation is given, and we can easily find out the slope of this equation by using this formula. So m1 is equal to 2. If you compare this equation with this one, m1 is equal to 2. And the required equation is perpendicular to this, so we apply this formula to find out the slope of the required equation, which is minus 1 over 2. And this formula we apply to find out the equation of the line. Line is passing through point A, and slope we have already found out. So we apply these questions. These are the points for point A, and this is a slope. So rearrange it, we ultimately get this equation, which is the required equation, which is passing through this point A and perpendicular to this one. Now come to the second part. In second part, we have to find out the distance between A and C. First, we find the coordinate of point C. C is in between the midpoint of A and B. So we apply this midpoint formula to find out the coordinate of C, which comes out minus 1, 1. Now we apply the distance formula, to find out the distance between A and C. A is 3, 1 and C is minus 9, 1. So put these values in this formula. Ultimately, we get 12 units, which is the distance between these 2 points. So the distance between these 2 points is 12 units. In our next video, we will tackle last 5 years questions from 17 to 23 papers questions of coordinate geometry by unique four-step techniques. Goodbye.